Literal equations and formulas. Let's go over this worksheet. So solving literal equations, it's where you're solving an equation with more than one variable, and you're trying to solve for a single variable. The general key is just pretend everything else is a constant and just solve for that variable like you normally would. That's the idea. So let's do some. Okay, let's do a quick review first. A little spiral review. Order of operations. Remember, order of PEMDAS. Please excuse my dear Aunt Sally. And multiply, divider at the same level. Add, subtract at the same level. They're like the same thing. You just go left to right. So this first one here, we're going to do parentheses first. So 5 minus 2, 3 is 2. And then I'm just going to rewrite it. This is the main thing a lot of my students forget. It's like, hey, let's rewrite it first before we do anything else. So plus 2 squared. And then we're going to go, okay, exponent is next. So there's an exponent, 2 squared. That means 2 times 2, which is 4. So that's 4. So I'm just going to rewrite it one more time. 7 minus 2 plus 4. That's all add, subtract. So we could go left to right. 7 minus 2 is 5. 5 plus 4 is 9. There we go. Over here, we're just going to add up like terms. So we could have all the x's. 7x minus 6x is 1x. 1 plus 2 is 3x. And then add the constants. We could add 7 plus negative 1. So that is 6. So plus 6. There we go. Oops. Another order of operations. This is actually important. A lot of people mess this one up. So let me write PEMDAS. Please excuse my dear Aunt Sally. Now, the key thing here is that this is actually not a parenthesis. Parentheses, we have an operation like over here in between them. This is just multiplication, 3 times 2. And what goes before that is exponent. We actually got to do the exponent first. The most common mistake people make is they multiply 3 and 2 together. And really, you have to do the exponent first. Do 2 squared first. So 2 times 2 is 4, 2 squared. So this becomes 3 times 4 plus 1. 3 times 4, multiply first, so 12. 12 plus 1 is 13. Okay, let's go to the actual work from this lesson, literal equations. So here's example 1. Keep in mind we want to solve for x. We want to get x by itself, but there's a q in the way. Like I said before, all we have to do is pretend it's like a constant. Just try to get rid of it like you normally would. We're going to subtract q from both sides and get our answer. So pretty much treat this like a normal problem. Here's my line. Whatever I do this, I got to do this side. I want to get rid of that q. So let's subtract q from both sides. Q's cancel out. I get x is equal to r minus q. And that is it. You can't do anything else. R minus q is just the answer. That's what x equals. So let's try the next one here. M equals m plus 3n equals 7. I want to solve for m. So I'm trying to get m by itself. Here's my equal to sign. We gotta get rid of that 3n. So let's subtract 3n from both sides. M is equal to 7 minus 3n. And again, that's all you can do. These cancel out, nothing happens. I cannot combine these. You're done. In many ways, this is one of my favorite lessons because it's simpler than it seems. You know, people have a hard time with it. I guess because it's more abstract. So same idea here, solve for m. So we want to get the m by itself. So first thing I do, like it's a normal problem. We want to get this by itself, so you get rid of anything that's extra. We gotta get rid of this 8 here. So let's subtract the 8 from both sides. And then again, these do not combine. This is an n, this is an 8. You can't combine them. So just leave it the way it is. Minus 5n minus 8 equals, those cancel, 4m. And then now I'm almost done. I can get rid of the 4 though. So just divide both sides by 4. And then there's my answer. M is equal to negative 5 minus 8 over 4. Oops, negative 5n. Negative 5n minus 8 over 4. And if you want to, you actually rewrite it. You could separate it and give yourself this answer. So you write each one separately. Oops, 8, that'd be minus 8 over 4. Also known as negative 5n over 4 minus 2. So that one or that one, equally fine. I don't care, really. Next one, they want you to solve. This is actually one we're gonna do a lot, especially coming up. Solve for y. I want to get the y by itself here. So I'm gonna try to get the y by itself. So let's get the y by itself. I gotta get rid of that 2x first because that's in the way, right? I just want to get this guy. Trying to isolate this guy. So get rid of the x's first. Minus 2x. Those cancel. I get 3y equals. Now again, here I cannot combine them. They're separate. So I'm gonna write 12 minus 2x or negative 2x plus 12. And then we want to get rid of the 3. So you can divide everything by 3 and you're gonna get y equals 12 divided by 3 is 4. 4 minus 2/3 x. And I guess I could also written it just all of it over 3. Right, again, either way is fine. Let's move on. solve this for f. We want to get f by itself. This is actually one of my favorites. So I'm trying to get f by itself. Well, what's going on right here is d and g are getting multiplied. Like, these are all being multiplied together. And what's opposite of multiplying? Dividing. So we're going to divide by d and g. And then the d's cancel out, the g's cancel out, and you're left with f equals h over dg. And that's it. That's all you could do. Next one, solve for x. Actually, kind of a similar idea. I'm going to rewrite this so it's a little easier to see. I'm going to try to get x by itself. Well, right now, x is being divided by a minus b. So, opposite of dividing, let's multiply by a minus b. Remember, the w is on top. Like, I know this is a fraction. You don't see a fraction here. Technically, it's over 1, and we're multiplying by over 1. You don't have to write that, just in case you're wondering, like, how's it work? Well, anyway, over here, these cancel. You just get x. And over here, we have w times a minus b, which you could leave like that. I guess some people might distribute and get this. As always, both answers are fine. Either one's fine. I should probably put an or here. Okay, let's move on to the next one. Ooh, an x on both sides. So it is more difficult, but let's work on it. So what we have to do here is let's first distribute, because I'm trying to get the x by itself. There's no way right now. So let's distribute. Distribute that a to both sides. Distribute this 2 to both sides. So over here, I'm going to get 8x minus 8a equal signs where it is. My line's pretty bad. Distribute the 2 here. So you're going to get 4a minus 2x. Now what we want to do is kind of what we always do. You want to get the x's on one side and then the a's on the other side. So let's get rid of the x's first. So anytime we have a variable on both sides, we're trying to get that variable on the same side. Let's move over that x. So plus 2x plus 2x. Now keep in mind, you get the line it up, right? The 2x goes here, it goes here. So you get 10x minus 8a equals 4a. Now let's get rid of that 8a. Let's add 8a to both sides. And we're going to get 10x equals 12a. And we're just trying to get x by itself, so let's get rid of that 10. So divide by 10, divide by 10. What I do left side, I do the right side. And x equals 12a over 10. Or if you want, divide them both by 2, and we're going to get 6a over 5. A little reduced. And there we go. Let's move on to this one. We want to solve for m in this case, but same idea. We have an m on both sides, so let's distribute. So no other way around it. 12 goes into both of these, so I get 12m plus 36x equal sign. Distribute the 18, 18x minus 54, 54m, like that. And then same idea. We want to get the m's on the same side. So over here's my m. I'm gonna move it over to there. This is I know it's the bigger number, but it's a negative, so I'm gonna move it to that side, make it a little easier. Go plus 54m, plus 54m. Those cancel. I get 66m plus 36x equals 18x. And again, now we want to get rid of the 36x. We're trying to get m by itself, so get rid of anything else that's not an m or attached to it. So get rid of that. Minus 36x, and I get 66m equals negative 18x divided by 66. We get m is equal to negative 18x over 66. And you could reduce that if I divide them both by 2, get 9 over 33. That still reduces, divide by 3, negative 3 over 11. So that's the best answer for my m. Okay, let's move on. 9, we're trying to get b by itself. We actually did one that's similar to this one a little bit ago. I'm just doing a little different to make it easier because there's a fraction on the right side. But the same concept. I'm trying to get b by itself. What's going on with b? It's getting multiplied by a and c. And they're all next to each other. It's being multiplication. What's the opposite of multiplication? Divide. Let's divide by ac. And I'm going to write it like this instead of just dividing by it because we have a fraction here to make it, I think, cleaner. So I'm going to multiply by 1 over ac. So divide by ac. Do the same thing on that side. The a and the c cancel. We get b equals, we have fractions here. So remember, you just multiply across and we have fractions. So 1 and then 2 times ac. 2ac. And there you go. Next one here. Actually, kind of very similar. So solve for h. We're trying to get the h by itself. So first thing I'm going to do, let's get rid of that 1/3. I'm going to take this a little bit step by step. Let's get rid of the 1/3 for it. We don't like fractions. So opposite of 1/3 is you want to times it by 3, because right now you're being divided by 1/3. So let's times both sides by 3. We get 3v, the 1/3 and the 3 cancel out, you get pi r squared h. Now again, we're trying to get h by itself. This is the guy we're trying to get by itself. So what's going on? It's getting multiplied by these two. What's the opposite of multiply? Divide. So once we put a line, we're going to divide by pi r squared. Again, if we want to, we could do like we did last time where we make it a fraction, 1 over. It works the same either way. These cancel, these cancel. I get 3v over pi r squared is equal to h. That's our answer for that one. Let's move on. Solve for c here. So there's actually a couple ways to do it. You could cross multiply, that works. Actually, let me do it 2 ways, just in case. So I'm gonna do it 2 ways. And the key here is we want to solve for c. So the first way to do it, probably the most popular way a lot of people have. There's an equal sign between, so I could just cross multiply these two. I could put on the top side, and then multiply these two, AD. And now, again, I'm trying to get C by itself. So what's going on right now? C is getting multiplied by B, so do the opposite, divide by B. The B's cancel, AD over B equals C, and you can't do anything else. That's your answer. Other way you could have done it here, since the C is on top, and all that's going on is you're being divided by D, why don't you just multiply both sides by D? So this is another way of doing it. These cancel, I get AD over B. And again, why is it on top? Because we multiply a default over 1. So when you multiply fractions, you multiply across. So AD over B. That's got the exact same answer either way. Next one, solve for x. So I want to solve for the x right here. With this, you generally want to work outside in. So let's get rid of the 1/3 first. I can't subtract the w because the 1/3 is in the way. So gotta get rid of that guy. So opposite of dividing by 1/3 or multiplying 1/3 is opposite. This is being divided by 3. Opposite of that is times it by 3. So that's a nicer way of saying that. So it's a gobbledygook. These cancel. I get 3y equals x plus y. W, sorry. And then solve for x. So get rid of that w. That's minus w from both sides. So I get 3y minus w equals x. And there we go. Let's move on. A little deeper thinking. Error analysis. There we go. Okay. The student solved ky plus 3x equals 8 for y as follows. Step 1, ky equals 8x, 8 minus 3x. That looks good. No issue there. They subtracted 3 for x from both sides. Step 2, y equals 8 over k minus 3x. There's the error. So what happened here is they didn't divide both of them. You need to divide both terms by k. So let's just recreate it. When you divide by k, or any number, you have to divide everything by that number. So not just the first thing, everything. So we're going to get y equals 8 over k minus 3x over k. Like that. Okay, let's move on. Next one, fill in the missing space. So we started here, given the equation. Now they want me to multiply both sides by 6. So we're going to multiply both sides by 6. And that gets us, let's write it here. Those will cancel xy equals w6. And then it says, how did I get from here to here? Well, to go from here to here, from this line to this line, we divided by y, it looks like. So we're going to divide division property. Let me go back. Division property. I guess the first side was multiplication property. Okay, there we go. So we take the division property to get that. Let's go. That wasn't my favorite question. I don't like the way it was set up. Anyway, next one. In a hockey game, the goalie may not play the puck outside the isosceles triangle behind the net. The area formula for a trapezoid is this. Area equals 1/2 base 1 plus base 2 height. Where B and 1 are the parallel bases and h is the height. So like we have here. Here's our trapezoid. That's my base 1. That's my base 2. That's the height. So they want us to solve for B1 in this formula. So they gave us this formula. They want to get B1 by itself. So let me rewrite that. So area equals 1/2 B1 plus B2 height. They want us to get B1 by itself. First, let's get rid of that 1/2. Always want to like another fraction. So we're going to multiply both sides by 2. So now we're going to have 2a equals B1 plus B2, but that's still being multiplied by h. So next, let's get rid of that h. We don't want that h. We're trying to get this guy by itself. Let's get rid of that h. So right now it's being multiplied, so let's divide. So I'm going to have 2a over h equals b1 plus b2. And now to get b1 by itself, we just got to subtract that b2. So we're going to get this 2a over h minus b2, that's my h, equals b1. That's my answer there. Next problem, next part of the problem. The height is 11, the far base b2 is 28, and the area is 572. Find the near base b1. So basically, they want us to use our formula here. They're telling us 11 is the height, so that's my h. That's 11. b2 is 28, so that's right here, 28. And the area is 275, so 275. So we're going to have 2 times 275 over 11 minus 28 equals base 1. Now that I would use a calculator for to get my answer. And if I put in my calculator, I would get 22 equals base 1. There we go. Next one, a rectangular baking sheet has an area of 117 inches squared and a width of 9 inches. The area formula is length times width. Solve the formula for length and then find the length of the basket. So they want us to, first they want to solve for L. So we have this formula. And I'm trying to get L by itself. Well, L and W are being multiplied because right next to each other. So what's the opposite of multiplying? Dividing. Let's divide both sides by W. And then we're going to get, let's cancel out, A over W equals L. So that is our formula. And then find like the baking sheet. So we have to plug this stuff in. We know the area is 117. That's this guy. We know the width is 9. So that's this guy. So we're going to get 117 over 9 equals our length. I don't know what that is, but let's do it. That is 1, so 9, 27, so 13. I should have known that. So 13 inches is the length of that baking sheet. Okay, let's move on. Every two-step equation can be written as ax plus b equals c, where a, b, and c are constants. Solve ax plus b plus c for x. So we're trying to get x by itself. So let's try to get that x by itself. Well, if I want to get the x by itself, first thing I'll do is get rid of that b. So minus b from both sides. We're going to get ax equals c minus b. Again, I cannot do anything else besides write c minus b. And we're not done. I got to get x by itself. That a's in the way. So divide both sides by a. I'm going to get x is equal to c minus b over a. Or again, if you prefer, you can always separate it. Divide each thing by a. That also works. X equals c over a minus b over a. Each way is fine. Okay, what's the next question? Use your formula from part A to solve 3x plus 7 equals 19 by substituting a equals 3, b equals 7, and c equals 19. Okay, we have this formula. Let's use that one. So x equals c minus b over a, and now we know what all those parts are. So x equals 19 minus 7 over 3. All right, just substituting everything in a is 3, b is 7, and c is 19. And then we're going to get 19 minus 7 is 12. 12 over 3 is 4. X equals 4. So that's a nice way of doing that. Okay. Last couple. Solve for h here. Now, there's only one h. So I actually don't think it's too bad. Here's my a. There's my equal sign. I'm trying to get h by itself. So first thing I do is get rid of all of this. So we get rid of that. Right now it's being added. So let's subtract it. Minus 2 pi r squared. Minus 2 pi r squared. So I'm going to get a minus 2 pi r squared equals 2 pi rh. So we're there now. Again, we're still trying to get h by itself. Next step, well, what's going on with the h? Right now it's being multiplied by 2 pi r to come out of the circle. It's going to multiply by all this. So opposite of multiplying, dividing. Let's divide everything by 2 pi r. 2 pi r. So these are going to cancel. That's going to cancel. I'm going to get h equals a minus 2 pi r squared over 2 pi r. And I accept that. Again, if you want to, you can also separate it. You could have done the other way where you divided everything that by 2 pi r. You could have done it this way also. I guess this way is a little more fun because over here you get to cancel things out. The 2's cancel, the pi's cancel, one of the r's cancels, and you get a over 2 pi r minus r. But again, to me, equivalent. I don't care which way you do it. This way is fine. That way is fine also. Okay, let's go. I think it's the last one. DOK level 3. Explain why the steps used to solve linear equations for a variable are exactly the same steps used to solve a regular one variable equation like 2x plus 5 equals 13. Use the term inverse operation in your explanation. Oof. Well, when you do literal equations, when solving literal equations, you treat all variables as constants. And when so as constants, like when as constants. And then we'll put to isolate a variable, to isolate the wanted variable, we need it's an n, to use inverse operations to get the variable alone. And that's why. I'm not sure that's the best explanation, but that's what I could think of. Anyway, that's the worksheet.